Shanesburg, and today we're going to talk about how to use the TI84 to create your scatter plot and look at your quadratic regression. Now, the data set we're going to use is the data set right here, where we're going to plot the x values against your y values. Now, in order to do this, we're going to use our stats function, which is going to be this button on your calculator, and we're going to use different functions behind it. So, if you first go to your calculator and you hit your stats button, what we're going to do is we're going to edit the list. So we're going to edit, and the list we're going to create is going to be a list of L1, and that's going to correspond to this list right here in a column format. And L2, it's going to be in a column format. So we're going to type in a 1, a 10, 20, and a 30. And just keep going down the list, get down to 60. Now, for an L2 column, we want it to be our y values, so we're going to go 14.8, hit enter, and it's automatically going to go to the next row. 13.9, 13.4, 13.5, 15.9, 20.2, 22.0. So we have just entered our data as a list into the TI84. Now, what we're going to do is we're actually going to plot this data, the x and the y values, and in order to go about that, we're going to use the stats plot button. Now, the stats plot button, it's this value right there, this button right there. So in order to use that, since it's the blue feature, we're going to hit the second button, and what that's going to do is it's going to activate all the blue features on this calculator. So the second button and then the stats plot will get us to what we want to get for a scatter plot. So we're going to hit enter because we want it to be the first plot here. And here we got our plot which is already on. Now, if the plot was already off, we're going to take this and turn it on because we actually want to use this plotting feature. And we want our plot to be the scatter plot. So the scatter plot is this one right here where the cursor is blue. So we'll hit enter and we go to that plot. So we just turned on the scatter plot function for this calculator. Now, to actually see the same plot, what we're going to do is we're going to go to a zoom function, and we'll scroll down to the number 9. That's going to be our zooming stats function. And this gets our stats plot. So this value right here, this box, is going to correspond to the x value is 1 and the y value is 14.8. Now, the next one is 10. We'll go over 10. Then 20, 30, 40, 50, and then 60. It's a little darker up there, but that's going to be this entry. So you're creating your ordered pairs. You're ordering the x and the y, and you're plotting it. Ordering your x and the y, you're plotting it. Your x and your y, and you're plotting it. Now, if you notice from this scatter plot, it doesn't have a linear model to it. It doesn't look like a linear function. It has more of a quadratic function. It has a dip down. So that's the reason why we want to look at our quadratic regression here. Now, to look at our quadratic regression, what we're trying to do is we're trying to find a quadratic function, or a equals x squared plus our bx plus our c. What we're trying to do is we're trying to figure out what our a is, what our b is, and what our c is. And that's going to be a function that's going to approximate this data that's given to us here. Now, in order to go about doing that, once again, we're going to use our stats feature. So let's get out of here real fast. So let's go to our stats feature again. Now we want to use our calculation. So instead of using the edit, we're going to go to the calculate. Now, the feature we're looking at is a quadratic regression. Careful and don't hit the quartic regression here or the cubic. We're looking at the quadratic regression. ScatterPlot has a quadratic function to it. So we're going to look at our list of L1 and L2. So we want these lists. Then we want to calculate. We're trying to figure out our A, B, and C. So we hit enter, and we get our values out of this. So our values that we get going to be these quantities. Now, if you just go ahead and note these down real fast, we're going to use these values here in a second to actually address another question that's in the homework here. And the other question was, the question was asking, what is the worst year going to be for this given data set? And what's going to be the average miles per gallon for that year? Remember, our X corresponds to the number of years past 1940, and Y corresponds to the average number of miles per gallon. So in order to figure out what this value is going to be, remember, we're using a quadratic function. So if you have a quadratic function, and this right here, their A, that's going to be positive quantity. So that's going to say the parabola is going to open up. So we're going to look down here at the very bottom, we're going to find our vertex. And the vertex is actually going to tell us the worst year. It's going to be the minimum. So let's go back to our plot real fast. Now, so you can see, quadratic function looks something like that. And the worst year is going to be somewhere in this range. But where is it going to be? That's what we're going to find out. Now, to use these values to calculate, we can go back to our formulas for the vertex. So we take these values and we plug them in. We get 17.36. So about 17.4 in that range. And that's the number of years past 1940. So it's going to be roughly about 1957. Take off a few months. So we take this value and plug it in. We're going to get approximately 13.4. 13.4 is going to be the worst for your average miles per gallon. And that's going to occur in 1957. Okay, well, now that we actually have this data, this information here, let's actually plot this function. And actually to plot it, now we're going to use our y equals function. So we're actually going to plot a quadratic function, and we're going to use the values that we found for the quadratic regression. So we're going to have 0.00511, and we can stop there if we like, or we can keep going with it. So this is going to be a good approximation right here. So we have 5 significant figures we're going to work with. And we're going to have an x. Now, x is going to be a quadratic function, so we want this to be squared. Then we're going to add our negative 0.17753 times x. Then we're going to add our 14.94686. So what we're doing is we're plotting this function. We just input it into our calculator. So now we actually want to plot it. Now, as this quadratic function is being plotted, notice that it's really close to actually what the data is going to be. Now, it's not going to actually be what the scatter plot is, but it's a good approximation for what it actually is going to be. So if you actually look at the scatter plot, you can use this function, this quadratic function, to approximate the scatter plot, the data that's